What we're going to be doing in this workshop exercise is making a simple animated teeter-totter or seesaw IMVU. We'll first create a simple mesh, setting up an armature, using the helpers to position the seat nodes, and then adding a simple animation before exporting that for IMVU. So let's get started. To make the seesaw then, the first thing we need to do is load in the IMVU template file. So File, Open, select your hard drive, your folder location, and then the file, and then click Open Blender File. This loads in the template file with the avatar helpers, their armatures, and a default cube and its armature, all of which can be used to make various furniture items for IMVU. Now before we go any further, it's best to save the file so we have a base file to go back to should there be any problems. So File, Save As, and then just call this Seesaw version 1 and save as Blender file. Once we've done that, we can make a start on the seesaw. We can leave everything as is for the moment because the avatar dummies help with scaling the mesh relative to IMVU and the avatars. So the first thing we need to do is center the cube that we'll be using to make the seesaw. So select it, left click, hold the green arrow, hold Control and drag. That just centers the cube. Duplicate this, Shift D, right mouse click to release the object, click the blue handle, Control, drag it up and release to let go and set the position. So what we have is the upper cube, which will be the plank, the lower being the upright around which the plank will pivot. Next, all we need to do is resize the objects, and this is where the avatars come in handy. Press numpad 3, numpad 5, this gets us into side view. Scroll out and move around the scene so we can see everything better. Select the upper item that will be the plank. We want to scale this along a particular axis, so press the S key, that scales, and then the Y key to lock the axis, and just hold the Control key down, move the mouse away from the object center to rescale. When you're happy with the size, left click to confirm and set the size. Again, press S, this time Z. We want to thin the object. So move the mouse towards the object center. Again, once you're happy, left mouse click to confirm. And that's the plank. We can move this into position. Hold Control and about there, just above the bone that we'll be using as our pivot point. Select the lower object, repositioning the scene where necessary. Press the S key, Y, scale inwards, left click to confirm, setting the object's depth. We want to set the height, but rather than scaling using the center of origin as the point from which scaling occurs, we can use the cursor. So press the full stop or period key on your keyboard and watch what happens to the widget. It snaps to the cursor. Now if we press S again, we'll see that scaling happens relative to the position of the cursor. So S, Z, hold Control and scale upwards, left click to complete the basic construction of the seesaw mesh. To reset the manipulator widget back to its original position, press the comma key. Then once done, and before we go any further, save a copy of the file. So File, Save As, version 2. It's a good idea to get into the habit of doing this so that you save incrementally each time you make a major change to the mesh. and save as. Now before we go any further, we need to fix a couple of issues that are raised as a result of scaling or shaping a mesh in the way that we've just done. The first of these problems is texture distortion. So to explain this better, press numpad 5, making sure the mouse cursor is over the 3D view when pressing the numpad keys. Then moving around the scene, what we can see on the mesh is some texture distortion due to the way that the mesh has been scaled and squashed the surface size and therefore the distribution of the texture over the surfaces. We need to fix this by editing the UV maps. Now before we do this, what we need to do is set the object's scale relative to its physical size. And we do that by taking a look at the scale and dimensions of each object and then setting them so that the scale along each of these axes is 1. And to do this, we simply select the object and then Control A to access the Apply menu, and then keeping an eye on the scale values to the toolbar on the right, watch what happens when we assign rotation and scale to the mesh. Each of the X, Y and Z scale properties updates to reflect the change made to the mesh. Select the plank, and again you can see that that's got quite a high Y value because it was scaled along that axis. So again, select, Control A, rotation and scale. Now to correct the UV map, what we can do is use seams. So if we press the tab key to go into edit mode, Z key to switch to wireframe just to make the selections easier, or click the viewport shading button, select edge from the select mode buttons and shift right mouse click a number of edges around the mesh, preferably places where the seam won't be as noticeable. Then Control E, mark seam. This will highlight the selected edges. Press A to deselect, and you can see the highlight. A to reselect all, and then U to redo the UV map. Select Unwrap. To see the difference, just flip back into texture mode. We can then see how updating the UV map has fixed the texture distribution over the mesh. Do the same again to the upright, so exit edit mode, select the upright, tab into edit mode, and the same again, select your edges, Control E, mark seam, deselect, select, and U for unwrap. And again go back into texture view, and we can see the difference again already. Exit and save a version of the file. Three, and save as. Now for animation, there are essentially 3 components to what we need. There's the furniture item armature itself. This is what IMVU uses to position the object within the world. The rotation of the arm, which is the animation that we actually want. And then there's the position of the avatar armature relative to the swing and the animation sequence. This can be briefly illustrated by selecting the plank, pressing R and then X to lock the rotation around the X axis. We can move the mouse just to see a rough approximation of what the animation would look like. In other words, what we're trying to do is rock the seesaw back and forth while keeping the avatars locked to either end of the plank. To do this, we need to rely on several specific bones within the avatar armature. Crucially, these 2 bones, the handle and the seat node itself. These are the two bones that are crucial to animate relative to the seesaw action and the furniture item's armature. So what we need to do then is duplicate the two end positions that we need. Select the seated dummy helper and its armature, shift right mouse click, and then duplicate both with shift D. Again, right mouse click to release, and then move them roughly into position. Same with the original that we duplicated, and move that into position. Again, holding the control key down to snap to the grid. Rotate this set of objects around so that it's facing into the seesaw. So press the R key, press the Z key to lock to the vertical axis, hold control key down and just move the mouse to rotate 180 degrees, left click to confirm. To position them properly relative to the seesaw, press numpad 5, numpad 3, and then using the widget, holding control down again, just position them so that they are approximately in the same location at either end of the seesaw. And before we go any further, save a version of the file. This is important at this point so that we have a set of armatures that we can reset back to should we make errors. We don't want to load a file and find that we've joined all the armatures together, which basically means going back even further, potentially losing more work than necessary to find the raw armature data. So File, Save As, version 4, and save as Blender file. With the dummy avatars roughly placed, we can then go ahead and set up the seesaw armature. Right click the furniture item's armature. We can zoom in. Press Tab key to enter edit mode. Right select the top control sphere. Press the E key and holding control drag up. Left click to confirm and set the bone's position. This bone will act as our pivot. Now the way this works is that animated furniture items are no different from normal items, except that particular sections of the mesh are parented to specific bones of the armature using something called vertex groups. Now in order for this to work, we need to know the name or names of each bone. Although the following can be done in either object or edit mode, for the moment just tab out of edit mode and in Object Data Properties activate Names, and we can see the names of each bone. What we can do is go back into edit mode and rename that bone by clicking Bone Properties, left clicking in the input box and typing a name, pivot in this case, enter. We can leave body as is and root as is. Now because we extruded this bone from body, it will be connected, so the parent relationship between the two bones is already set. As you can see here, the parent of the pivot bone is the body bone. With that done, tab out of edit mode, select the mesh, tab into edit mode, make sure that everything is selected. In Object Data buttons, scroll down to Vertex Groups. This should be blank. Create a new one by clicking the plus button. Call this Pivot, and note that its spelling is case sensitive, so it needs to be all lowercase. P-I-V-O-T, enter, and this is important, assign. Make sure this is done. We can check that by using select, deselect. Similarly, tab out of edit mode, select the upright, tab into edit mode, Again, make sure everything is selected, and this time create a vertex group called root. Note that the R is capitalized. So left click, root, enter, and assign, and again check the assignment and tab out of edit mode. Now, as a quick test, select the armature, control tab, or you can select pose mode from the drop down. Press the R key to rotate. Now, depending on which version of Blender is being used, there's a step missing here. What we need to do is assign a relationship between the mesh and the armature, and we do that by selecting the mesh, going into the modifier properties, click add modifier and select armature. In the object property, click and select the armature that's associated with the furniture. In this case it's just called furniture.rig. Select that. Repeat the process for the upright, which may be a bit tricky to select. So zoom into the scene where necessary, and again object modifiers, add modifiers, armature. Then as before, set the object to furniture.rig. Now if we animate that pivot bone, the seesaw moves. So we're halfway there. Next thing to do is to associate the avatar armature with the seesaw armature, and we do that by joining the two together. So once again, save the file. Before joining the armatures together, check their position relative to the seesaw. So press numpad 5 to go into perspective. Rotating around the seam, we can see they are to one side of the seesaw. So press numpad 5, numpad 7 to go into top down view. Shift right mouse select. Holding shift key down again, right mouse select, and just move them into position. Holding control to snap to the grid and then releasing once in place. Once that's done, numpad 5 to go back into perspective mode. Once that's done, what we need to do next is position the avatar so the bum is sat on the seat. So again, numpad 5, numpad 3, so that we go into side view. Whilst these are still selected, hold control, click the blue arrow and move upwards. Then holding shift key down, we can snap to smaller increments and position them relative to where we want them to be. Then release to set in place. Before we connect the dummy armatures to the furniture armature, what we can do is reposition the pitcher and catcher nodes so that they sit parallel to the ground. So select the armature, tap into edit mode, shift right mouse select, holding control key down again, just drop them down to the ground level. Hold shift key down if necessary for smaller increments, and then release, setting their position. Tab exit, select, tab enter, same again. Control shift, drop it down using smaller increments. Release to set in place. Once we've done that, we're almost ready to connect everything together. So again, if you want, save the file. So as mentioned previously, the relationship between the bones is important. Effectively, what we want to do is animate just the seat node and the handle, whilst the catcher and pitcher nodes remain grounded. This means that we have to parent these two bones to the root bone of the armature, whereas the seat node and handle node need to be parented to the pivot. In doing that, it means that when the pivot moves, these bones move as well. Before we join everything together, we need to unparent the dummy meshes from their armatures. So, right select both of them. This is just the meshes. And then using Alt P, open the Clear Parent menu and select Clear and Keep Transformation. What this does is it unparents the connection between each mesh and each armature, but it keeps the meshes in their current position. This means that we can use them as positional devices relative to what we've been doing to check to make sure that the seat nodes are where they're supposed to be. Once that's done, select the armatures, making sure the furniture armature is in object mode, so using the mode selector, select object, and then we can connect the two together using Ctrl J. And same again on the other side. Right select the armature and the furniture armature, and then Ctrl J. At this point we want to save a version of the file. So File, Save As, version 7. Now the names associated with each of these bones is important. We have 2 seats, so we need them numerically named relative to there being 2 seats. So although one is called O2, the other is also called O2, but it has this append of 0.001. We need to remove that. The easiest way to do that is using the outliner panel, which highlights all the items that are in the scene. The armature for the furniture item is already selected and highlighted because it's the active object. Click the little plus sign, which will reveal the contents of the armature. And then we can expand this a little bit so that we can see better what we're doing. Move the mouse over the border, left click, hold and drag to expose more of the names. The simplest way to change a name is to make sure the object is selected, press the Tab key, and then holding the Control key down, left click one of the entries that needs to be amended. This will highlight the selection for editing. So go ahead and left click in there, delete 1, move to the end and delete that and press enter, and do the same again, hold Control and left click, place the cursor, and again 1, and again 1. Make sure that sitting is uppercase with an uppercase S, and there is a full stop or period between the number and the function, which is the sitting. Next we need to change the parent-child relationship between the bones. We do that from Bone Properties. So click on that to select. You may need to scroll down to reveal the option, and we have Parent. Left click a bone in the list above. It will highlight in the 3D view. Left click in the input field and select the bone that we need to parent to. In this case, for these 2 bones, the seat and the handle, that would be pivot. A dotted line will appear indicating the relationship. So select handle, and again repeat, pivot, and do the same on the other side. Seat 01, pivot, handle 01, pivot. Click the plus to drill down into the armature so we can see the relationship, and then with the remaining bones, left click select, and this time choose root, and then repeat this for each of the remaining bones. Catcher 02, pitcher 01, catcher 01. And what this does is it parents these bones to the root bone, which stays fixed along the ground, so when the seesaw moves, these bones won't. With that done, the armature is pretty much set up. So we can test this by pressing the Tab key to exit edit mode, and then using Control Tab, switch to pose mode, or select pose from the mode selector. Highlight the pivot bone, press the R key. If the bone relationships have been set up correctly, this should have the handle and seat nodes move with the pivot. This then means that the armature is set up and ready for animation. So again, save a version of the file before we do that. Most armature or bone-based animation is done in the action editor for IMVU, and we get to that by selecting the dope sheet, and then from the editing context drop-down, select action editor, which will contain a list of bones that were associated with the original furniture armature. We can remove these by making sure that they are selected, so press the A key twice and then press delete. This clears the animation strip, so we don't have any old data present. Now, the principle of animation is to use things called keyframes. A keyframe is effectively just a pose locked to a timeline. Over a sequence where there are several of these keyframes or poses, as the time or duration transitions across the poses, the change between each pose is what gives us the animation. So what we have to do is create a set of these key frames or poses in the timeline. What we can do to set a baseline is, leaving the scene as it is, press the A key to clear any previous selections, then A again to reselect the entire armature, and making sure that we're in pose mode, then press I to insert a key frame. Select Lock Rot. That's location rotation. Scaling is not relevant for IMVU, so just use Lock Rot. What will happen? A new set of entries will appear, each of which is associated with a single bone of the armature. This is our base pose. What we then need to do is set 2 or 3 additional poses or keyframes for the see and the saw action of the seesaw. So click somewhere else in the timeline, left mouse click, or you can left click, drag and hold to set the timeline, choosing 100. Select the pivot bone, press the R key, hold Ctrl and then rotate the bone by moving the mouse to set a new pose position. Left click to set and then press the I key to set the keyframe for that bone. Again, Lock Rot. What we can then do is test that. Left click, hold, drag back and forth between the 2 keyframes. And again, set a new keyframe, this time around the 300 mark. Back in the 3D view, press R again to rotate, hold Ctrl key down and rotate the seesaw the opposite direction. Left click to set, press the I key to insert another keyframe and select Lock Rot, and that sets our 3rd position. So if we toggle back and forth between the 2, and then around the 400 mark we need to return the pivot back to its default position. So holding the Control key down again, press the R key and just rotate that back into position. Left click to set, press the I key, Lock Rot, and that's our final position. So what we've effectively done here is created a start point, an end point, both of which should ideally be identical, and the actual transitions between those 2 points at frame 100 and 300-ish. And as we transition across the frames, we can see that the seesaw actually seesaws. Now, to loop this for playback so that we can see it without dragging this back and forth, what we first need to do is set the sequence length to 400. In Render Properties, scroll down to Frame Range, Control left click end frame and type 400. Enter. To see the animation, just use Alt A. Now, as we can see, that's terribly slow. So what we can do to speed that up is change the distance between each of the frames. So press Escape to stop the playback, and then individually select right mouse click each keyframe, press the G key, and reduce the amount of space between each frame. And again, G key, left mouse click to set in place, G key, left mouse click to set in place. We can zoom into this sequence, scrolling up and using the middle mouse button to grab the view. To set the frames with more precision, so G key, press the G key and reposition each frame more precisely. As we've adjusted the sequence length, we need to do the same thing with the end frame. So Control left click and change that to 150 in this instance. And then using Alt A again, we can see that the sequence playback is much quicker this time round. And again, press Escape to stop. Once a basic sequence has been created, the final step is to set the frame rate property. For IMVU, that's 30. So over in the render properties, find frame rate and select 30 from the list of available options. With that set, on playback, Alt A, the speed of the sequence will be slightly quicker, matching the frame rate of IMVU. Once the animation sequence and frame rate is set, we'll then have the basics of an animated furniture item that can be exported for IMVU. So before doing that, save the file again. Before exporting for IMVU, make sure the armature is in object mode and that any meshes, so that's the plank and the upright, are joined together to form a single mesh. So Shift right mouse select both and then use Control J to join them together. Double check that that hasn't caused any issues, which means toggling back into pose mode and just rotating the pivot bone, and that's fine. Go back into object mode, and then for exporting, load the script, add-ons, import export. If it's already loaded, it will be shown in the import export scripts list. So just scroll down to find it, activate it, or click install from file, browse to the location of the zip file, and follow the on-screen instructions, and Blender will automatically install the script ready for use. It's then just a question of activating, closing preferences, select the mesh first, the armature second, and then export. And then from the list of options on the left, skeleton, mesh, animations, XAF, deselect morph animation, select materials. We don't need to write scene ambient color. Leave the frame rate set at 30, which is picking up the property that was set previously. and simply export. And that's it. Again, save the file so that we've got a reference point to go back to for future exporting. File, save as, version 10, and then next putting the files together in IMVU. With IMVU open, go into create mode as normal, derive a new product, rooms and furniture, furniture, which will bring up the chair, go. Then what we need to do is simply replace the default chair material with our mesh and armature. So click Add XMF, browse to the folder where the exported files were saved, select, open, apply, and there's our seesaw mesh. Click on Config, click Add XSF. Again, you should already automatically be in the same location as the mesh. Apply. Check the seating. Everything's fine. Now for the animation, click the Actions tab, Add, and then we can do one of two things. If we want the animation to play when the item is loaded into the room, type stance dot idle with a capital I, set number of ensembles played to 0, the type is room, after playing pick the same ensemble. Then we want to add our XAF, so click the Add XAF button. Again, you should load into where the files were saved previously. Select, open, and apply. And what should happen is the animation will automatically play. If we need more control over this, so the animation only plays when the avatars sit in a seat, we have to change the way the trigger works. And for this, we need to create two, because there are two seats. So back in trigger, delete idle, and type sitting with a capital S, hyphen, seat 01. Leave everything else as is. Apply. Now you'll note that the animation no longer plays until we sit in one of the seats. If we sit in the opposite side, the animation will stop, so we need to create another action, add, and this time stance dot sitting hyphen seat 02, which is the second seat, and as before 0 room, pick same ensemble, and we can select the animation previously loaded, apply, and check. And both play at the same time. We can then check this with the actor avatar loaded, so click debug, add actor, and add an actor. On the add actor tab, just go ahead and place the avatar on the seat, and there we have the animation. What you may need to do, as with most animations, is synchronize the two together. As a final addendum to assembly, if we want to replace the texture that's associated with the seesaw, in the Meshes tab, click Add XRF. Again, browse to the location where the file was saved, select, open, and to assign our texture, click the Edit button, select the texture, open, and apply. And there we have our seesaw with seat activated animation.